Hello Math 30-1. Today we are going to look at the remainder theorem and factor theorem. So to start off, we're just going to do a little bit of synthetic division here. So if we remember, if I want to divide this function by this divisor, I'm going to first, using synthetic division, I'm going to first make x plus 1 equal to 0, solve for x, so I get x is equal to negative 1. Now I'm going to make my little box system here for synthetic division, have negative 1 there. And we look here, I have x to the power of 3, so we have 1x cubed. We have negative 2x squared. And we're missing the x's here, so there are 0 x's, and that is one thing where we always got to remember to put in. So we have 0 x's, and then we have negative 4. Okay? So let's start my, it's negative 1, so let's start my synthetic division. First I'm going to carry down the 1. Negative 1 times 1 is going to be negative 1. We combine these together. Negative 2 plus negative 1 is negative 3. Negative 3 times negative 1 is 3. Plus 0 is 3. Negative 3 times negative 1 is going to give me, or 3 times negative 1 is negative 3. And that's going to give me negative 7. So now if I rewrite this all out, I am going to have, we have this part here, this product is equal to x cubed minus 2x squared minus 4 is actually equal to, we have our divisor. If you remember how to write this out in a multiplication sentence, it's going to be x plus 1. And then we are going to multiply that by what we did for our synthetic division. So we are going to have 1x squared minus 3x plus 3, and that is all right here. Then we have to subtract my remainder, which is negative 7. So that's my remainder. So now we're going to get into more or less what is the remainder theorem. So for this here, we're going to look at this here when we're going to put in negative 1 for x. So that's going to be p negative 1 is equal to, we have negative 1 to the power of 3. And then we're going to have minus 2 multiplied by negative 1, and we square that, and then we're going to subtract 4. Okay? So negative 1 cubed is the same thing as negative 1. Negative 2 times negative 1 squared. Negative 1 squared is positive 1, so that's just going to give me negative 2. And we're going to subtract 4. We combine all these together, I get negative 7. So then, by putting in my value here, into that and solving it, we end up getting my remainder, or in this case the remainder. So next part here is, we're just going to look at this here. So when this product is divided by x plus 1, so when this function is divided by x plus 1, the remainder is equal to p minus 1. In that case, okay? So, the remainder theorem. So this next part here is just going to kind of explain what the remainder theorem is. So we're always going to put the remainder theorem is, we're looking at it as a polynomial function, px, is divided by a binomial. So x minus a, okay? The remainder obtained is equal to the value of the polynomial where x is equal to a. So that's essentially what we did up here. I just made x equal to a. Alright? Now, what the remainder theorem does is we do division. So, and here we're going to prove it. If I have the product, so a polynomial of x is equal to something multiplied, a divisor multiplied by the quotient plus the remainder. Okay? So we're going to replace the divisor. We know the divisor is some binomial, which is x minus a, and we're going to put that in for the divisor. So my divisor multiplied by the quotient plus the remainder. That is how we wrote it up here. We had our divisor multiplied by the quotient plus the remainder is equal to whatever my product is. Okay? So we continue this off. We have x minus a, and now we're going to substitute a in for x. So now when I look at it, we're going to end up having a subtract a. Well, that's always going to give me 0. So then we end up having 0 multiplied by whatever my quotient is, and then we plus the remainder. So 0 multiplied by anything is 0, so that gives me my remainder. And that is pretty much the proof of the remainder theorem. Okay? So now we're going to look at some examples of how to use our remainder theorem. So here's the first example. We want this polynomial function, 6x cubed minus 4x squared plus 8x plus 6, and we want to divide that by x plus 1. So the first thing we're going to do is, I'm going to solve for x here, so x plus 1 is equal to 0. So we're going to look at when x is equal to negative 1. Alright? So we're using the remainder theorem, so I'm going to have my polynomial when x is negative 1 equal to 6, negative 1, the power of 3, minus 4, negative 1, squared, plus 8, and we're going to have to the negative 1, and then we're going to plus 6. Okay? Well, I look at this, negative 1 cubed is negative 1, so that's going to just be negative 6. And then we have negative 4 times negative 1 squared is going to be the same as 1, so negative 4 times 1 is negative 4. And then negative 1 times 8 is going to be negative 8. And then we plus 6. These 6's cancel off. We solve this. I'm going to end up getting negative 12. So I have a remainder of negative 12 as an answer. So now let's try our second one. We're dividing this polynomial function by 2x minus 1. So that's my binomial. So we're still going to solve. We're going to say 2x minus 1. And we're going to make that equal to 0 and solve for x. So I'm going to get 2x is equal to 1. X is equal to 1 over 2. Alright? Now, we're going to plug this in for my function. We're going to do the function instead of x, we're going to do it of 1 over 2. So I'm going to have p 1 over 2 is equal to 6, 1 over 2 cubed minus 4, 1 over 2 squared. Then we're going to have plus 8 times 1 over 2 and plus 6. Okay? Continue this off. We have 1 over 2 is the same as 1 over 8 times 6 is 3/4. Then we're going to have negative 4 times 1 over 2, which is 1 over 2 squared is 4, so that's just going to be negative 1. And then we're going to add 8 times 1/2 is 4, and plus 6. Okay? So I combine these here. I'm going to end up getting 6 plus 4 is 10, minus 1 is 9, so that's 9 3/4, which is the same as 9 times 4 is 36, plus 3 is 39 over 4. So my remainder is equal to 39 over 4. So class example 2, we want to find a when the remainder is 131, and we have our polynomial function here, and we're divided by x minus 3. Okay? Well, this looks complicated because now our unknown is actually in the polynomial function. But it's not really that bad. We're going to start off by using synthetic division, which is a method we've done before. So here we go. Make my little synthetic division thing. Here we want when x is equal to 3. I'm going to solve and make it equal to 0, so I'm going to put a 3 there. And my first term of my function is 2, my first leading coefficient. And then my second coefficient is going to be minus 1. Oh, there's no x squared, so I put a 0 for x squareds. Then we're looking at my x's. I have an a for x's, and then we have an 8. Okay? So we're going to just follow our normal division. So I go 3 times 2. 3 times 2 is 6. 6 and 1 is going to be 5. When we add those together, 3 times 5 is going to be 15. 15 plus 0 is 15. Then here we're going to go 3 times 15 is going to be 45. And then we're going to end up getting, it's minus a, no mistake there, 45, subtract a for this part. Okay? And now we're going to go a, and then we're going to add 8 to this here, which will end up giving us 143 minus 3a. Alright? Okay, so now when I look at this, this here is my remainder. And we know my remainder is equal to 131. So we're going to set that up. We're going to have 143 subtract 3a is equal to 131. Okay? Now, we're just going to solve for a. So I'm going to move my a's to this side and my numbers to that side. So I'm going to end up getting 12 is equal to 3a. Divide both sides now by 3. And I end up getting a is equal to 4. Okay? Now let's try b. b, we're going to use the remainder theorem. It looks complicated, might scare you a bit, but it's not that bad. So we're just going to plug in what we know. So first of all, we know that P3 is equal to 3 to the power of 4 minus 3 cubed minus a times 3 plus 8. Okay? Now, we know that P3 is my remainder, so my remainder is actually 131. So I'm going to put in 131 is equal to 2. Now 3 to the power of 4 is 81, so that's going to be 2 times 81. And then we have minus 27, and 3 times minus 3a plus 8. So I'm going to continue this off. I'm going to get 162 minus 27 minus 3a plus 8, 131. And now we're just going to solve for a. Alright, so when I move this all over, I'm going to end up getting 143 minus 3a is equal to 131, which is very similar to what we're looking over there. Move the 3a to that side and the 131 there, so I get 3a is equal to 12 and a is equal to 4. Okay, so those are two methods of doing it, remainder theorem or synthetic division. Okay, so now, our next question here looks rather complicated. It says, find the coefficients c and d given the following equation, where the polynomial function of 2x to the power of 4 plus d x to the power of 3 minus cx squared plus 5x minus 8. Okay, where the remainder is negative 41 when divided by this, and the remainder is 74 when divided by that. Now this at first looks complicated. You're looking and you're saying, oh boy, we have two variables that I'm trying to solve for. But that's not that bad, because looking at this, we may have two variables we're trying to solve for, but we have two quotients and the remainders. So as we found out before, we can make many formulas from them. And if we can make two different formulas with two variables, then we could use substitution elimination like what we did in grade 10 and grade 11 to help solve for the rest. So let's start this off here. So first of all, I'm going to look at when we have x plus 3. So that's going to give me negative 3. So we're going to go p, the polynomial function, where we're substituting in negative 3 for x, which is going to give me 2, negative 3, to the power of 4, and then we're going to go plus d, negative 3 cubed, and we're going to minus c, and that's going to be negative 3 squared, and what's the next part here? Plus 5 times negative 3, and then we're going to subtract 8. Alright? So we're going to now just start multiplying this out, but we know this is my remainder, so that is actually equal to negative 41. So it's like negative 41 is equal to, multiplying this out, this is going to give me 162 plus, minus because we have negative 3 to the power of 3 is minus 27. And then we're going to have negative 3 squared is positive 9. And so it's going to be minus 9c times negative c. And then we're going to have minus 15 and then minus 8. Okay, so I'm going to keep on solving this here. And I'm going to end up getting, moving all my variables to my left side of the equation, I'm going to get 27d plus 9c is equal to 180. Now looking at this, I could simplify this a bit more. I could divide everything here by 9. So that's going to end up giving me 3d plus c is equal to 20. Okay? Now we're going to do my second equation because we have two variables here, so that means we normally need two equations to cancel off the variables or to eliminate one of the variables. So my second one here we're going to look at when x is equal to 2. So we're going to look at P2. And that's equal to 2 to the power of 4 plus d2 cubed plus minus c, and that's 2 squared. And then we're going to go plus 5 times 2, and then we're subtracting 8. Okay? Now continuing on with this, we know that this function here, the remainder is 74, so we can plug in my remainder, thanks to a nice little remainder theorem. 2 to the power of 5, because it's just one more, is going to be 32. And we're going to have plus 8d minus 2 squared is going to be 4c. And then we're going to have plus 10 minus 8. Okay? So now we're just going to simplify everything here. I am going to end up putting all of my variables on that side and all my numbers on this side. So I'm going to be left with negative 8d plus 4c is equal to, I'm going to end up getting 40. Okay? Negative 40. So wait, double check. Yep, negative 40. So now I could divide everything here by actually negative 4. Okay? Or, so everything's nice and positive. So I'm going to end up going here, it's going to give me 2d minus c is equal to 10. Now I have my two equations. One equation here, one equation here. And I could use either substitution or elimination to get rid of a variable and solve for one variable. I'm going to use here elimination, the adding and subtracting of the two equations. So we have 3d plus c is equal to 20. And then we're going to put underneath 2d minus c is equal to 10. So I could either add or subtract here. If I add these two equations together, my c's will nicely cancel off. So I'm going to be left with 5d, because these add together to get 5d, these will cancel, is equal to, these add together, give me 30. So in other words, d is equal to 6. Okay? Now that I know that d is equal to 6, I could use substitution to find my other one. So I know I'm going to substitute this back into this formula here. So I have 2d minus c is equal to 10. So 2, and we're going to put in 6, minus c is equal to 10. So I'm going to move the c on that side, 10 there. So I'm going to have 12 minus 10 is equal to c, and c is equal to 2. Okay? So now I know my two answers are, we know d is equal to 6 and c is equal to 2. Alright? So that wasn't that bad once we just solved it out.